Find the area of the region bounded by the graph of y equals x squared minus 3x minus 4 and the x-axis. All right, so here, I didn't draw the graph here. I want us to, without knowing what the graph looks like, figure out which function is the bigger function and which function is the smaller function. But before we can do that, we have to figure out our bounds of integration. So that means our left endpoint and our right endpoint. So we need to set the two functions equal to each other. So the x-axis, here where it says the x-axis, that's equivalent to the function y equals 0. So we need to set these two functions equal to each other. We need to set x squared minus 3x minus 4 equal to 0. And that gives us x squared minus 3x minus 4 equals 0. That becomes x minus 4 times x plus 1 equals 0. So this tells us that our endpoints are at x equals positive 4 and x equals negative 1. And so we need to take the integral from minus 1 to 4 of our bigger function minus our smaller function. And the way we can determine which function is our bigger function and which function is our smaller function is we just need to pick an x value between negative 1 and 4 and see which function, y equals 0 or y equals x squared minus 3x minus 4, produces a bigger value. So I'll pick, let me use a different color here. I'll pick x equals 0 because that's between negative 1 and 4. If we plug 0 into y equals 0, well, the output is obviously 0. And if we plug 0 into y equals x squared minus 3x minus 4, well, the x values are 0, so we get y equals negative 4. So that tells us that this function here, y equals x squared minus 3x minus 4, is smaller than y equals 0. It produces smaller outputs. And so, when we take this integral here, we want to take the integral from minus 1 to 4 of 0, because y equals 0 is our bigger function, minus x squared minus 3x minus 4 dx. So let's solve that. That becomes the integral from minus 1 to 4 of, and here I'm distributing this negative out to everything, of minus x squared plus 3x plus 4 dx, which is minus x cubed over 3 plus 3x squared over 2 plus 4x evaluated from minus 1 to 4. And so we get minus 4 cubed over 3 plus 3 times 4 squared over 2 plus 4 times 4, that whole quantity, minus negative 1 cubed over 3 plus 3 times minus 1 squared over 2 plus 4 times minus 1. And if we simplify this down, and here I drew a picture of the actual graph so you can see an idea of it. But before we get there, let's go ahead and continue solving this. So this becomes minus 64 over 3 plus 3 times 16 is 48 over 2 plus 16 minus negative 1/3 plus 3 over 2 minus 4. Distributing this negative to everything, we get minus 64 over 3 plus 24 plus 16 plus 1/3 minus 3 halves plus 4. And then I'll save us all some time here. That simplifies down to be 125 over 6. That's your final answer. And here's, like I said earlier, here is a graph of the function. So you can see the curve is smaller than the x-axis, so that's why we subtract the curve from the x-axis. All right, one more example. Find the area of the region bounded by f of x equals 3x cubed minus x squared minus 10x, and g of x equals minus x squared plus 2x. So again, here we aren't given left and right endpoints, so we need to find the points of intersection. And we can do that by setting the two functions equal to each other. So we have 3x cubed minus x squared minus 10x equals minus x squared plus 2x. And now we solve. So if we add an x squared to both sides, both of those cancel out. And so we get 3x cubed minus 10x equals 2x. So now we can subtract 2x from both sides, and we get 3x cubed minus 12x equals 0. Now we can factor out 3x, and we get x squared minus 4 equals 0. So this becomes 3x times x plus 2 times x minus 2 equals 0. So that tells us that the points of intersection are at x equals 0, x equals positive 2, and x equals negative 2. So we have 3 points of intersection here. And so that gives us 2 regions to worry about. Okay, the region between negative 2 and 0, and the region between 0 and 2. And so just like before in the last problem, we need to figure out which function is bigger where. We can pick a number between negative 2 and 0. So we pick a number in negative 2, 0. And we pick a number in 0 to 2 to figure out which function is bigger on the interval. So I'll pick negative 1 and 1. F of negative 1 is, what was f of negative 1? 3x cubed minus x squared minus 10x. So it's 3 times minus 1 cubed minus minus 1 squared minus 10 times minus 1. Let me verify that. 3x cubed minus x squared minus 10x. Perfect. And g of minus 1 is negative minus 1 squared plus 2 times minus 1. And so these work out to give us f of minus 1 is 8, and g of minus 1 is negative 3. And so on the interval from minus 2 to 0, we have f is bigger than or equal to g. And so now we have to pick a number between 0 and positive 2. I'll pick positive 1. So f of 1 is 3 times 1 cubed minus 1 squared minus 10 times positive 1. And g of 1 is minus 1 squared plus 2 times 1. And these work out to give us f of 1 is minus 8, and g of 1 is 1. And so on the interval from 0 to 2, we have g is bigger than or equal to f. So we have 2 intervals here on which one function is bigger than the other. How do we solve the area between them? We break up this problem into 2 smaller problems. What we want to do is we want to find the integral from minus 2 to 0 of f minus g. Remember, we're subtracting g from f because f is the bigger function. And to this, we want to add on the integral from 0 to 2 of g minus f. And so, focusing on this integral right here, that'll give us the integral from minus 2 to 0 of f minus g. And remember, f was the function 3x cubed minus x squared minus 10x. And we're subtracting off the function g, which was minus x squared plus 2x dx. Before we solve this, it's a good idea to simplify, so we can distribute this negative into everything, and then that gives us the integral from minus 2 to 0 of 3x cubed minus x squared minus 10x plus x squared minus 2x dx. And so we get the integral from minus 2 to 0 of 3x cubed. These x squareds cancel out. Minus 12x dx. And so that gives us 3/4 times x to the 4 minus 6x squared, evaluated from minus 2 to 0. And so that'll be 3 over 4 times 0 minus 6 times 0 minus 3 over 4 times minus 2 to the 4th minus 6 times minus 2 squared. And so this is obviously just 0. So we have minus 3 over 4 times 16 minus 6 times 4, which is minus 3 times 4 minus 24. So that's minus 12 minus 24, which is positive 12. So this integral here, the integral from minus 2 to 0 of f minus g, gives us positive 12. Now let's turn our attention to the integral from 0 to 2 of g minus f. So we have the integral from 0 to 2 of g minus f. Now remember, f minus g simplified down to be 3x cubed minus 12x. And that is irrespective of the value of x. So it doesn't matter where x is on the line, f minus g is 3x cubed minus 12x. So that tells us whatever the value of x is, no matter if it's between 0 and 2 or negative 2 and 0, or if it's not even in that interval, the value of g minus f will be negative 3x cubed plus 12x. Okay? So the value of g minus f is the integral from 0 to 2 of negative 3x cubed plus 12x dx. Okay? And again, that's because f minus g equals 3x cubed minus 12x. And so g minus f, which is just negative f minus g, is going to be negative 3x cubed minus 12x. So that'll give us negative 3x cubed plus 12x. Okay? So let me go ahead and erase this and we can solve that integral. So we have the integral from 0 to 2 of minus 3x cubed plus 12x. So that'll be minus 3 over 4 times x to the 4 plus 6x squared evaluated from 0 to 2. If we plug in 2, we get minus 3 over 4 times 16 plus 6 times 4 minus, and if we plug in 0, we just get a big fat 0, so we can ignore that, and this simplifies to be minus 3 times 4 plus 24. So this ends up being minus 12 plus 24, which equals 12. And so that means this integral here gives us positive 12. This integral here gave us positive 12. So the final answer is 12 plus 12 equals 24.